At the time of this recording, there wasn't a tremendous amount of material. I did find this perfect video from Edward Thompson, one of the PMs on Azure DevOps. Essentially, I took that demo and extended it, added some graphics, took a slightly different coding approach in the final solution. Welcome to this demo. We're going to talk about continuous integration with Azure pipelines and GitHub. My name is Bruno Turkley. There's a few technologies and concepts that we'll work with. The first of which is Azure Pipelines, which is the cloud-based tooling from Microsoft that allows you to do continuous integration very easily. Now, none of this would make any sense if you didn't have source code, and in our case, we're going to use our repo as GitHub. In doing so, we'll be able to branch, pull, and merge software changes so that developers can safely contribute to a software project. We're going to be focusing mostly on continuous integration and testing, but there's also a more advanced side to this, which is continuous deployment. What you notice in this diagram is we want to go from development to production, and there's a bunch of steps in between which are going to be fully automated. Naturally, it makes sense that if there are any failures along this pipeline, the deployment will not take place. And the whole point is that we release software that's been tested and ready to go to production. The important thing to recognize in this diagram is that the pipeline is comprised of a series of steps that begins when the developer checks in code into GitHub. Jenkins gets called via a webhook notifying Jenkins that source code has changed. Jenkins then begins the process of downloading the assets from the GitHub repo and executing a number of steps like linting, unit tests, even acceptance tests, perhaps building a container along the way for the application. In the section below, you can see that if any of the steps fail, the red box indicates that the pipeline halts execution, notifying the user that something broke the build. The idea here is that the entire pipeline needs to execute successfully if the application is to make it to even staging. In terms of getting the application into production, there are different approaches here. Some approaches start to roll out gradually into the cluster and see how the application responds out in the wild. It might even involve doing what they call A/B testing or canary deployments. The good news here is that prerequisites are free. You need to have a GitHub repo as well as an Azure account. Both of them, again, available for free. This video is going to demonstrate the following steps. I'm not going to read them all out loud to you, but the basics here is that I'm going to show you how to set things up. I will also demonstrate the workflow whereby an outside developer wants to contribute to my GitHub repo and essentially issue a pull request or a PR, and then I demonstrate the steps to getting that pull request merged into the main or master branch of the GitHub repo. Along the way, I'll demonstrate a user trying to submit a pull request that has unit test errors, and from there I'll show the repair of those errors and then ultimately showing the merging of the pull request into the master branch. And then in addition, I will talk about a status badge at the end. What you're looking at here is that Azure DevOps can be a place where you create these projects that have pipelines. These pipelines are associated with GitHub repos, and so you can have any amount of these projects and or pipelines. Now, these projects live in organizations, and so underneath your Azure DevOps account, you can have multiple organizations with multiple projects in each organization. So in the demo that comes next, what I'm going to do is I'm going to start with an organization called B Turkley 0365. I'm going to add a project called Project Calculator, and then within that project, I'm going to add a pipeline. And that pipeline will be associated with a specific GitHub repo. So that's all coming up next. So what you're looking at here is dev.azure.com. I am creating the project, Project Calculator. I'm going to click Create Project, and at this point, create a pipeline. There's a number of things we can create, but we're interested in a pipeline. So we'll do a new pipeline here, and then at this point, we'll link it up to our GitHub account. So notice here, once again, we're going to click on GitHub, and from there, we need to authorize ourselves to get access to the GitHub account. I've logged in, and you're going to see a list of repositories. The one we are interested in is Bruno Turkley/Calculator. What you see here in the upper left corner is what we just talked about, the association of a project to a pipeline and a pipeline to a GitHub repo. Now, just to make things more concrete, you'll notice that Bruno Turkley/Calculator is my GitHub repo with the source code. And notice also there below that there are two main areas we want to focus on. First, where the core logic lives in the API. That's essentially where numbers are passed in to this API and arithmetic is done on those numbers. Now also notice here is that there is a test folder, and that's where the unit tests live. And those are the unit tests that get automatically executed by our GitHub Dev Azure pipeline. So here we are at the calculator repo. Let's take a look at API. That's where we have the method. We'll click into the controllers folder. We'll take a look at arithmeticcontroller.js. We'll go down to the operations area, and we'll notice that there's the add method that gets called out. Notice it has kind of a funny syntax, plus A, plus B, etc. We'll circle back to that and talk about what we'll do to fix that. So at this point, let's go back up to the parent folder, go into the test, and really verify that there are unit tests here. So we're going to go maybe take a closer look at the add unit test. So here in the beginning, we'll do something simple. We will create a new project, and to that project in the future, we will be adding our pipeline. But let's first just create this new project and start the process. You can see we're going to do step 1 now, and that simply means we're going to create a new project within an organization, could be any organization, at dev.azure.com. Now once your project is created, there are a number of things you can add to it. What we're interested at this point is the pipelines component, so let's do that next. One of the first things that we're going to do is create a pipeline and then associate a GitHub repo with that pipeline. Once that association is made, that means the moment a developer checks in code or commits code to a GitHub repo, the pipeline will automatically kick off, download that code, and apply all those steps we defined for our pipeline, such things as applying a lint, or doing unit tests, or even integration tests, or perhaps even deploying to some staging environment. Creating a pipeline is quite trivial. Once your project is created, just go to the Pipelines button, click it, and then once again click New Pipeline, and you're good to go. So here in step 3, no surprise, we need to associate our GitHub repo with that pipeline that we just created. We talked about this before, so let's just go ahead and do it. So here we are back at dev.azure.com. We're going to authorize for our GitHub repo. Once we do that, we'll be presented with a list of repos. The very first one is the one we want, Bruno Turkley/calculator. Now remember, once the association is made, it will put a special file in our repo. We're going to go ahead and click the starter pipeline here because after all, let's do this from scratch. It will try to recognize the code base. Here's azure-pipelines.yaml. It's a special file that we can use to actually type in the commands we want to execute as part of the pipeline. So for now, let's just go ahead and save and run this file. We'll actually add the steps later, the stuff for unit test, acceptance test, build, all of that. So at this point, the dev.azure.com portal is showing us the commands that are executing in a special process dedicated to doing just this. This is a job running essentially, or a build. And in a sense, what it's doing is building what's in Azure Pipelines .yaml. So we just finished step 3. A special file has been added to our GitHub repo. You'll notice that everything executed correctly. Let's go navigate back to the repo directly from the portal, and you can see azure-pipelines.yaml, a special file we use to type in all our commands. And we can go ahead and edit directly right here at the GitHub repo site. And notice here there's a series of commands that we're going to type in to actually execute the pipeline. So now this is the core area where we actually type in all the needed commands for our particular build goals here. We are talking about a node.js app, so we're going to be using npm commands. But if this were Java, or if this were Golang, or C, or any other language that is supported here, the commands would differ slightly. But the main point here is we're going to go back to the calculator repo and enter the commands into azure-pipeline.yaml. That's the file that gets executed automatically as soon as someone commits to GitHub. So just to paint a clear picture, you can see here that our pipeline has some lint, build, or test commands in there. That's what we need to type in. In our case, it will be specific to our node application. As we discussed, it'll be a bunch of npm commands, npm build, npm install, etc. We'll review that in a moment. The key thing here is that there's a relationship between our pipeline and our GitHub repo. There's this azure-pipelines.yaml file, for one thing, as a common ground. And in addition, there's a webhook that connects the two worlds so that when a developer checks in or commits code, the pipeline knows that it needs to execute to download the assets from GitHub and then perform all the commands in azure-pipelines.yaml. This is an important topic to understand, azure-pipelines.yaml. Again, when we made that association, the environment put that file into our GitHub repo. It acts as the central control plane for the pipeline. Every time we do a commit to the GitHub repo, this pipeline will execute, doing all the commands inside of it. Now also remember, there's a bunch of samples here. We talked about multiple languages being supported. This is just some examples that you can go and access and look at as some ideas. But of course, you can also add your own custom enhancements as well. You can see here the example file that we're going to type in. Basically, just a few things here. Notice we have a pool of VM images where the builds are taking place. In this case, an Ubuntu machine. Also notice the steps here. There's tasks and scripts. The key part actually is the script, because that's where you put the npm commands. The npm install, the npm run build command, as well as the test. Now, if a deployment were involved, you would add even more to this file. But we're just doing continuous integration, not continuous deployment, and that's why we're focusing on just those 3 files. So as the next step, let's go in and type those into our azure-pipelines.yaml file, and that will really constitute the pipeline that we want. So here we are at the repo. We're looking at azure-pipelines.yaml, and notice I do have those 3 npm commands that we need here to enable us to execute this pipeline. So I'm going to commit those, and I'm going to click Commit Changes here, give it a little comment, and at this point the pipeline has already kicked off, and in fact the commands we just typed in are being executed. So we can double click into our project here at dev.azure.com, and we can go and see the builds that are now taking place as a result of that most recent check-in. So here you can see the results. We'll click on the most recent build here, and we'll go over here to the log section, and you will notice that there's a section that has been added here because of all those commands we typed into azure-pipelines.yaml. Good news is the test passed, and so this was a successful build. So in this next scenario, step 5, we're going to pretend we're a developer that is actually interested in modifying some code at the repo. So we're going to walk through those steps, and at this point we're going to introduce the concept of branching, pull requests, and merges. So stay tuned for more. This is the next section. So the idea here is that the developer came along here and looked at the arithmeticcontroller.js file, and there on line 16 thought that they found some type of syntactic error. They see a +a plus b, and they think that's a mistake. So their best bet is to do a pull request, and that's what we're going to kind of demonstrate next, is what are the steps involved if you, the developer, want to make contributions to the source code. So here we are. We're at the repo. Some developer wants to modify the code. They're going to open up arithmeticcontroller.js, click on the Edit File button, go in and make the source code modification. And in this case, as we said, the developer thought there was a syntactic error with extra plus signs. They're going to go ahead and type in the corrections, put a little comment, of course, and then hope that the test pass once they commit this code. But we're not going to do just a regular commit. We're going to do a branch here, which is a way for a developer to take part of the code, separate it out, and then from there make the correction like we're doing now, and then do a pull request. So at this point, we're going to choose that second radio button, provide a comment, because we want to create a new branch. Hopefully, if the modifications are good, they will be rolled back in to the main branch of the repo. And let's go ahead and hit the Propose File Change button. A pull request lets you tell others about changes you've pushed to the GitHub repository. Once a pull request is sent, interested parties can review the set of changes, discuss potential modifications, and even push follow-up commits if necessary. Pull requests are nothing more than collaboration using a shared repository model. As you recall, we forked the repository or created a branch, and then the pull request is created from that. Okay, so at this point we are ready to create the pull request. We're going to go ahead and click on the pull request button. And once we do that, we're going to quickly realize the build is broken. That's why you see the red here. The unit tests have failed. So that means that we tried to solicit some changes that weren't proper. Notice, by the way, email was also sent indicating such failure. Okay, so at this point, let's go back to dev.azure.com and get some more details. We're going to go ahead and click on this build here, specifically the step that has the red marks, and here you can see the unit test that failed. And really what it did by making that change, it caused a concatenation instead of addition. So this is clearly an unwanted change. We do not want concatenation, we want addition. So let's quickly talk about what you can do if a pull request does not meet expectations. So once again, we will reject this pull request. We're not going to accept it. Let's take a quick peek here about the actual failure here. As we know, there were some file changes that broke the build. And notice in green what we changed it to, and the red is what we changed it from. So we actually made a mistake. So that means we're not going to do a merge of this branch into the main branch, and we will probably end up closing this pull request, allowing the original developer to go back and make changes that do not break the unit tests. So the usual scenario here is that we would not accept and merge these changes. We would notify the original submitter of the changes and ask them to fix whatever errors were encountered during their edit so that we could actually do a proper merge. Okay, so the point here is we want to actually go back and make this pass the unit test. So we're going to use the function parseFloat here to indicate that we want to do true arithmetic. Otherwise, we were doing concatenation of two strings. So let's go ahead and make that clear in the comment about what we want. And therefore, we should be able to resubmit this pull request and get it to pass the unit test. And we will verify that and do that as a next step. So what we expect the other developer to do is to actually recommit these new changes in the hope that they pass the unit test. So let's go ahead and do that. We'll add our comment. Again, we don't need to do another branch here. We just need to do a commit with the necessary fixes. So we'll go ahead and give a commit comment using parseFloat to force an arithmetic add, not a string concatenation. So once we do that, the pipeline will kick off and we'll once again run the unit test and hope that they pass this time. So now we're hopeful that those commits actually pass the unit test. We'll go over here to conversation and notice we see green here instead of red. All the unit tests pass. We go back to dev.azure.com and sure enough the pipeline indicates successful unit tests. So at this point we're going to just go even one level lower and look in the log files just to be 110% sure. Sure enough, everything passed and it's looking pretty good. So at this point, the unit tests have passed, and we are ready for that final step of merging those requests into the master branch of our GitHub repo. So it really is as easy as going into the conversation of the GitHub repo and clicking on the Confirm Merge button. That should just take a couple seconds to actually bring that into the main branch. And so at this point, the merge is successful. So just to review, you can see that a developer does a branch, goes ahead and does some code, commits, and then that ends up doing a lint, compile, unit test, etc. And if that's okay, the developer typically issues a pull request that gets reviewed. And if that pull request looks good, it gets merged into the master and then perhaps deploying to staging, etc. So in this final section, we're going to talk about adding a status badge to your README. The purpose of a status badge is to really give the status of the last build. And in our case, it's going to be that we had a successful build with Azure Pipelines. So it's really a way to give first-timers and old-timers an at-a-glance peek at the status of a project. So let's show you how to do that. We'll begin by going back to dev.azure.com, closing up all the windows and log files, and really just going back here on the left to the builds in the pipeline. We'll go ahead and click on the ellipses and choose Status Badge. We're going to go ahead and take the last one here and copy that code into the clipboard. And now it's a simple case of returning back to the GitHub repo and pasting in the status badge that is now in the clipboard from the earlier steps. Go ahead and click the Edit button here and then go to the appropriate spot, paste in that code, and go ahead and commit these changes. And in a moment, you'll see the status badge in the README file, giving outside users confidence that your GitHub repo will compile and test correctly out of the box. Some of you might be wondering, how do we actually deploy this app? Well, there are a number of ways, but here at this website, at the Azure property, notice there's a bunch of guidance here about how to zip up all the contents of the folder, and then basically, given a number of different alternatives, you can ultimately deploy this as a web app. So that's all documented here. There are just additions you do to the Azure pipelines.yaml file to get this done. So thanks for watching. I realize a lot of information, but here are the 10 steps that we did, with the very end adding a little bit about deployment if you want to add that to your continuous integration pipeline. We kept things very simple because some of these processes can get quite complex and quite sophisticated. Hopefully this will get you started and allow you to start leveraging GitHub repos with a proper DevOps pipeline. Thanks again.